Hey guys, welcome to day 53 of Codeforces Everyday until GM. Let's just jump into straight problem solving today. Let's try to get 3 done, if we can. Curse of the Frog. Interesting title. $1,200 rated. On an infinite number line at point 0 sits a frog. After many years of meditation, the frog has mastered n unique types of magical jumps. The ith type of jump allows it to jump forward by no more than AI units. In other words, if it was at integer point k after the jump, it can land at any integer point from k to k plus AI. But magic always comes with a price. It's been cursed. Before each b'ith attempt, among those, to use the ith type of jump, the frog rolls back CI units. In other words, if it was at point K, it will first find itself at point K minus CI, and after the jump, it can land at any integer point from K minus CI to K minus CI plus AI. The frog's goal is to reach the point with the number X using jumps while minimizing the number of rollbacks. Help the frog find the minimum number of rollbacks it will have to endure on its way to the goal, or determine that it cannot reach point X. Okay, so t equals int input for in range t. First line contains 2 integers in and x equals map int input split. In the following in lines, the description of the jump types is provided. The ith line contains 3 integers, so for I in range in a, the description of contains following. AB is equal to this. For each test case, if the frog can reach X, find the smallest number of rollbacks, otherwise print -1. Okay. So, what is actually going on with this problem? In times of magical jumps, the ith type of jump allows it to jump forward by no more than AI units. In other words, if it was at integer point k, after the jump, it can land any integer point from k to k plus AI. But magic comes with a price. Before each b'ith attempt, among the jumps, to use the ith type of jump, the frog rolls back CI units. So, okay. If it was at point K, it will first find itself at point K minus CI, and after the jump, it can land K minus CI plus AI, okay. So what's B used for? Oh, before each BIth attempt. Okay, so I'm definitely going to need to look at test cases to understand what's happening here. The frog can jump forward by 1 unit and will end up at point 1. Thus, the answer is 0. In the third case, it can be shown that the frog cannot reach point 4. In the first case, so our target is 1. The frog can jump forward by 1 unit because A, B, okay. In the third case, the frog cannot reach point 4 because number of jumps in the number of types of jumps the frog can make in its final target is X. So AI is I can't really understand what B is supposed to be. And then C is rewind. Roll back. Call rollback. Something like that. So, fourth test case. The frog can reach point 8. Jump using the first type by 12. Jump using the fourth type by 1. Jump using the second type by 10. Then it will sequentially be at the following points. So it's the first jump. We jump 12. We start at 0. Since it's the first jump, we roll back 11. So we're at negative 11. Then we jump 12. We're at 1. Then we use the fourth type. Jump by 1. Into the second. Wait, yeah, then we jump by 1. And then we're at 2. And then we use the second type. So we roll back 4. We're at -2. Plus 10 is 8. So this we want to. Okay, so in is the number of jumps. 8, the smallest number of rollbacks. Jumps equals this jumps dot append. So now we have an array of tuples, and then rollbacks equals 0, print rollbacks. Constructive algorithm, greedy math. So all I've taken away from this problem so far is that if rollbacks equals 0, attempts equals 0. If attempts mod jumps one does not equal to equals 0. Okay, we need to track current location as well. So if distance equals x, print rollbacks. Continue. Distance plus equals jumps 0 minus jumps 2. Question is, what do we put in here? Greedy. So you're saying we want to get as close to the jump as possible each turn? What did we do here? We did 12. The rollback always comes first. We did 12, 10, But we did 12, 1, 10. Doesn't matter the order. If we did 12, 10, 1, would we get to the same place? We would 12, roll back 11, so we're at position 1 still. And 10, roll back. Let's attempt 2, right? So we would roll back 10. It does matter because of the... Because we'd be at 7. And there's no 7. So I'm thinking we have to like do this backwards or something where we start at 0 and we try to get to 1. Or we try to get to... No, we start at target and we try to get to 0. We want to minimize the number of rollbacks. But then sometimes you just make it impossible if you greedily choose. Can you make it as close as possible? So 8 with no rollbacks. 2, 2. There's a 1 in 10 1. Well, wait, are these two separate? Fuck. Yeah, these are separate. Fuck. It's all of these. This won't cause a rollback if we use it first. So we go to 1. Okay. Then we use this one, which will cause a rollback. We get 6, so that's at 7. And then we go back to this one. That's 8. And we only rolled back once. So I don't really understand. Something in my understanding of this question is wrong. Before each bith attempt, frog or roll back. So if k minus c makes it'll work because we don't have to jump the entire distance of a, right? So we want to overjump if possible. We want to greedily use overjumps. But we always roll back first. In the sixth test case, 1 when our target is 10, we can jump 6 times. 0 to 2, roll back to 1, 3, and 5, roll back to 4, 6, 8, roll back to 7, 9, and we'll jump one more time for 10. It was quite complicated. I don't really have like an idea of where to start with this problem. We want to minimize rollbacks. So, if we can find a loop where we can abuse one type of jump, like until like right before the rollback, and then we can use the another type of jump, so type 1, type 2, during that rollback, then we can just do it. Right, so each jump we can abuse b minus 1 times. Among the jumps of this type. So that's good to know. It's not attempts in general. It's like how many times have you used that jump? So we should have an attempts array. Like attempts equals this 0 times len jumps. And then if attempts mod jumps, wait, if attempts what? If plus, it's like attempts plus 1 equals jumps 1, then we have to use this, and attempts or adding 1 to attempts. So we reset attempts this to 0. What if we use every jump b minus 1 times? Just to start off with it. We use this one. So we're at let me just cookie cutter out this test case. We use everyone b minus 1 times. We start 0, go to 1. Now our attempts array is 0, 0, 0, 1, 0. Now we can use any of them because so what would get us the closest? This would get us backwards. This would get us backwards. This would get us backwards. These two move us forwards. This moves us forwards the most. It moves us forwards 6. So 6. And we used it our reroll or rollback. So +1 rollback. And then we set back to 0. Now we can use anything again. Well, since we can move 6 each time, this just makes it for us. I think this is a strategy. So the strategy, from what I can think of, is first, use all types of jumps b minus 1 times. Second, choose the best c minus a. Well, it's not that simple. It's not just c minus a, because if we calculate the c minus a values, this will give us 1. This will give us 6. This will give us -2, -4, -5, right? But because this case resets to 0, we can use this for free once. So this could be -3 before. So it's actually c minus a plus well, it's negative c plus a. plus it's like how much value can we get out of each one of these before the reroll? We get each time we use it, we get C minus. Wait. How much value before the reroll is A times B minus 1? A is 1. So in this case of 1, 2, 5, A times B minus 1 is 1, plus negative 5 plus 1 is 4. It's equal to 5. We're adding? It's negative 5 plus 1 is equal to 4. Wait, what? This is not right. Our C minus A. C is 5 plus A plus 1. Alright, this is negative 3. So this is the okay, yeah, I think this is right. This is the value per rollback. We can calculate the value per rollback for each. Okay, so choose the best C minus A plus A times B minus 1 until end. I think that's it. So what do we actually need? We have an array of tuples. Distance equals 0. Array of attempts. We don't even need an array of attempts. We have a count of rollbacks. So I think for jump and jumps, distance equals jump zero times jump 1 minus 1. So what this should be doing, this times, it's 2, 1. So 1 times 1. If it's 1, then it's 0. So it's plus equals like this. Now, value per rollback equals array times len jumps, which should just be in. For rollback in value per rollback for we can do this all in one. We have value per rollback here, and then jump distance value per rollback for I in range in distance equals jumps I 0 value per rollback I equal to negative jumps I 2 plus jumps I 0 plus jumps I 0 times jumps I1 minus 1. Now we do x minus distance. We print x minus distance divided by max value per rollback plus 1. Well, if it's equals 0, then we don't need plus 1. We can do math.ceil. So it should be print x minus distance by max value per rollback. Okay. Fails first try as per usual. Received output 8. That's not right, so let's print after here. We should print distance and then print value per rollback. 1, 6, -2, -3, -5. That's right. So we're at position 1. We have 7 spots left to go. Is 6, right? So 7 divided by 6 is like 1.3. Oh, I need a parentheses. Well, I really don't like having to. We can do. Let's not do this. Let's not use math module here. If we double divide, go to. Let me just test this real quick. -2. So should just be like this. Boom. Uh, 6. There we go. Still failed on something. Division error. Our value per robot back could be 0, basically, is what it's saying. For so if max if we're going to calculate this twice, might as well put it in a variable. Now, what if the best value was negative? That's also a case I'm considering. Since say these were all our values for rollbacks from 1, 1, 2, 1, 1, 3, 1, 1, 4, we start, n is 3, we want to get to 8. Distance is 8, divided by -1 is equal to -8. Will we print -8? Okay. We should print -1. Zero will be the closest we ever get. So best value is 0 is less than or equal to 0. It's impossible. And our x will never be negative, right? Yeah. So let's try this. We didn't even need this variable here. Wrong answer. I hate these ones with test cases because it actually makes it so hard to debug. Expected 0 found -1. Which test case are we talking about? $57. This doesn't even go that far. Um, Well, what could it be getting caught on? There's clearly a test case issue, right? Expected 0. Found impossible. If it's like by default? Like I'm thinking maybe 3, 0. Well, x has to be between 3, 8. This pretty good prints -1. I see what's happening. So if it's greater than x is greater than or equal to x. This. Okay. I think that's the test case we were missing. There we go. We got it. Not too shabby. How long did it take us? 53 minutes. A little long, a little long. Let's do maybe some easier problems, like 1,000 rated. I do not want to drag this out. Yeah. Let's close all these. Next reordering. I'm glad I was able to figure that question out, though. It was a good confidence booster. You know, it means that I can actually solve like newer 1200 rated problems. It just takes me a little while. It wasn't even a hard problem. I would say I could figure out like where I was supposed to go like each step of the way. It was just like the ideas didn't come to me immediately. And it was very hard to piece it together at first, I will say. But okay. Let's do this problem. Max reordering. Given an integer array A consisting of n elements, denote FLR is the max, okay? Determine if there's any way to reorder the array such that for every I, F1I does not equal Fi plus 1n. In other words, for every split point I, the max. Determine if there is a way to reorder the array such that for every I from 1 to I, the max of 1 to I does not equal to the max of I plus 1 to the end. For every split point I, the max of the prefix must be different from the max of the suffix. So, okay. Test cases. T. Single integer int. N. A. Close list map. Int input. Dot split. Alright. So, given an array, the only choice for I is 1. Next, from 1 to I, from 1 to 1, max of A1, which is 1, it's 0, okay. And then I plus 1 is 2 to the end, so 2 to 2, A2, max 0 equals 1. Since 0 does not equal 1, satisfied. So they put 1 first and 0 second, okay? We can reorder this into 161005. If there's a way to reorder the array such that every I for I to n minus 1 gives a different number. If I was 3, 2, I is 3 plus 1 is 4, 0, 0, 5 is 1. Yeah. 2 is 2. If when I is 2, this would be, this would be 0 when I is 3. That would be 1. This would be 0. This would be 2. Okay. So how do we actually go about this? Rearranging the array. It's a sorting problem. So if we just sort 0, 1, we get different maxes. 0, 0, 3. Split here. Split here. This doesn't work. Right? 0, 0, 1, 1, 5, 6. You split here. Split here. We get 1, 0. Split here. We get 2, 0. Split here. We get 2, 0. Split here. We get 2, 0. Is it as simple as just sorting the problem? Okay, let's try like 1, 1, 2, 3, 5, 6, or something. 0. This is 1, 0. Let's try like, no, this is 2, 0. 2, 0. So is it just 0? Like, if I had 1, 1, 3, it's 0, 0. So that doesn't work. 1, 3, 1 is still 0, 0. It doesn't matter. The order actually doesn't matter. Move it back. 1. So it's like if it starts with duplicates. But wait, 0, 0, 1. Works. 003 doesn't work. 113 doesn't work. So 002 wouldn't work either, right? 1, yeah. These need to be in order. So if they repeat like this, so what about 03, 4? So this would want 1, 0. This would want 1, 0. Okay. Zero, 3, 3. 1, 0, 1, 0. So, okay, it seems like only the beginning kind of matters. Zero, 2. 1, 1. Doesn't work. 0, 1, 3. 1, 2. 1, 2 also. 1, 0. X is 1. X is 0. Do we just like check? Like split everything? Like what's the time complexity? We're given 1 second. 500. Like why am I just thinking of checking every result? No, like that actually seems like valid here. We sort it and then check every result. If there are no zeros, it's impossible, right? Because then both sides will be 0. That means if there's exactly 1 0, it's always possible. Because if there's no zeros, so 1, 2, 3, no matter how you split it, both sides will be 0. If it's 1, 0, 1, 2, 3, it'll always be possible because this side will always get 0, and this side will always be like the next bigger number. What about like, okay, we tested. So for both sides, we need 2. We need pairs of 2, right? For it to be possible, we need 2 zeros, 2 1s, 2 2s. If we have an odd, then it becomes this works, this works. This one's 2, this one's 0. This one's 2, this one's 0. This one's 3, this one's 0. This one's 3, this one's 0. No. Still works. This one's 1, this one's 2. This one's 1, this one's 0. this works. It's like 0, 0. So if a dot count 0 equals 0, it's impossible. Print no. Continue. Else if a1 or if there's 1 0, then it's always possible. Zero, 2 is impossible. So if there's 2 zeros, but if there's 3 zeros, 0, 0, 0, 2, still impossible. 0, 0, 1, 0, 0, 0, 1 is possible. 0, 0, 0, so like 0, 0, 1, 1, 2 is also possible. 0, 0, 1, 1, 3, 1, 2, 1, 0, 2, 0, 2, 0. So, okay, zeros are important, but ones are also important. And I think that's it. Twos don't matter. Like, numbers after 1 don't matter. If there's at least 2 zeros, there needs to be at least 1 1. Because then or else it will fall into a case of both sides want the 1. But after that, if it's like 2, if it's at least 2 zeros and it has at least 1 1, then one side will default to wanting the next biggest number. So if there's no 2's, then one side will default to wanting 2's, and the other side will default to wanting 0's. Right? Because 0, 0, 3, first split is both wanting and wants. Because we need to be able to pass all the zeros first. And in order to pass all the zeros through, we need ones. After that, it doesn't matter. So It's elif a dot count 0 is greater than equal to 2 and count 1 equals 1, and print yes. Else print no. What the? Wait, why is this not capitalized? Okay. Int input. No, yes, no. So what cases? Okay, is at least 1. Like this. There we go. I think this is the answer. Let's try it. We got it. Nice. We can do maybe one more problem. Beautiful string. Given a binary string s of length n, your task is to find any subsequence p of. Dude, they need to find everything in this such that sequence p is non-decreasing. That is, each character p is not greater than the next. Let x denote the string obtained by removing all characters of p from s while preserving the ordering of the remaining characters. Then x must be a palindrome. You only need to output valid subsequence p satisfies both conditions. If no such subsequence exists, output -1. Okay. What's our input? Like this, and then like this, and then s equals int input. If a solution exists on the first line, on the second line. Okay, so what are we trying to do? Given a binary string, find any subsequence such that it's non-decreasing, which means all the ones are in front, all the zeros are behind it. Let x denote the string obtained by removing all characters of p from s while preserving the order of the remaining characters, then x must be a palindrome. Okay, let's look at the notes. So, first test case, we're given a 1-0. remove an empty string resulting in x equals 010, which is a palindrome. Second test case, 001. This is non-decreasing, so we remove 01. The first case we remove an empty string, which means we don't remove anything. Alright. We remove 01, resulting in XO, which is a palindrome. P is non-decreasing. Okay, third case, 00111, resulting in an empty string. 01, resulting in 11. Which is a palindrome. So we basically remove P. Our resulting is X. And check if X is palindrome. If it's impossible, print -1. We output the length of the string we're removing and what we are removing. Okay. I'm getting kind of... Okay, P is non-decreasing, not X is non-decreasing. That's good to know. And X is the one that needs to be a palindrome. So first we need a way to check palindrome, right? Which we can basically... This is like a leak code question. Like, it's like if X equals X reversed, if it's not, well, if it is, that checks palindrome. Well, do we even need to check palindrome? Because, like, we know what we remove, right? And we're removing that for a reason. Is there ever a case where it's impossible? If one's in front, like 1, okay, 010, we can just remove empty string. 101, we can remove 101, we can just remove empty string again. 10, we can remove 1 or O. Let's take a look at. They didn't explain the second case. Damn it. Well, the third case has multiple answers, right? Everything, which is a palindrome. Okay. If you can remove everything, then remove everything, basically. It seems like. Hmm. In the fourth test case, in the fifth test case, 01. Like, we can just remove 1, 2. Which is a palindrome. So how can we determine if it's how is it impossible? Like 1, oh, I feel like it's never impossible, no? 1, 0, 1, 0, 1, 1. You can just remove 1. I can't think of a case where it's impossible. Uh, hmm. Your task is to find a subsequence. Oh, subsequence, not a substring. Wait, this makes it like very easy, no? Subsequence of a contiguous. So it could be like index 1, 3, 5. Wait, this makes it so much easier. Don't we just like remove all of one number? Like, it's never impossible. So like we just output all the indices of 5, 6, 3, 4, 1, 2, 3, 4, 5, 2, 3. Okay, so they're tricky. In their test cases, they all gave contiguous or continuous um, answers. But contiguous. I'm gonna look up this real quick. Def contiguous. Position next to. Not necessarily position next to. Okay, so basically we can just print all of one number. So like all the zeros or all the ones. It's like for I in. Okay, it's print s.count 0 for I in range in if si equals 0, print I. To print plus equals I. To print dot append I. To print equals empty array. And then we can also move this down here. Print. Okay. Have this here and print star to print. Zero. Do I need a +1 at all? You removed 2, 3. So it's 1, 2, 3. So yeah, we do. Like this. Okay. 1, 2. Okay, I think this is right. There we go. I got it. Took us another, what, like 15 minutes or so. Alright. If y'all enjoyed this video, be sure to like and subscribe. I'll see y'all guys tomorrow. Bye.